Hello students. So in the last class we have seen that there are ways of setting out of curves, and one of the method we have seen in the last class, that is offsets from long chord, that is perpendicular offsets from long chord, and today we will solve problems on that. Okay, so I am going to take up one of the problem from your question paper. So you just I will read out the question, and I expect you to note down that question in your notebook and try to understand the solution, right? So that is the reason why I am taking directly the problem from the question paper. So this question is from uh, January 2020, the latest one, and the problem goes like this. Two tangents AB and BC, two tangents AB and BC intersect at point B at signage of 150.50 meter. Full stop. Calculate all the necessary data for setting out a circular curve of radius 100 meter and deflection angle of 30 degree by the method of offsets from long chord method. Right. So this is how he mentioned with what method you are supposed to solve this problem. Right. So you are supposed to calculate the data necessary to set out the curve in the field by offsets from long chord, right? So what data he has given is there are two tangents AB and BC, and they are intersecting at a point B, right? So AB and BC, these are the two tangents. So this is A, this is B, this is C. AB and BC are the two tangents, and they are intersecting at a point B, and the signage of point B is given as 150.50 meter. So signage of point B is 150.50 meter. Right? Signage means distance of that point from the origin, from where the road has started. Right? So if it has started somewhere here, so by reaching this particular point, it has covered 150.50 meters. Then you are supposed to calculate the data necessary for setting out a circular curve of radius 100 meter, right? So if I have to have a curve, the curve has to be of 100 meter radius, right? So the radius has to be 100 meter. So I will write here, right? Then the deflection angle of 30 degree. So the deflection angle is this, that is delta, and this is given 30 degree, right? So I will write the major data given, r is equal to 100 meter and delta is 30 degree, right? So when I have to when I have to find out the data necessary for setting out the curve, what exactly they mean to say is you are supposed to find out perpendicular offsets, right? So the method is perpendicular offsets from long chord. So this is long chord, right? So perpendicular offsets from the long chord in the sense, so we will start with mid ordinate, where the mid ordinate will be, it is exactly at the center of the long chord. So mid ordinate will bisect the long chord exactly into halves, right? So L by 2 this side and L by 2 this side. So the total length of long chord will be capital L. Now this is mid ordinate, which is O0, isn't it? Now I have to divide into number of equal parts. So that I can do only when I know what is the total length of the long chord, right? So in some of the problems he will mention what interval you need to take for values of x, right? So at what distance from this I have to have the offset, right? So there might be one offset here, one more offset here, one more offset here. So in a similar way we will have number of offsets, right? So the interval between the offsets will be sometimes given in the problem. If it is not given, we are supposed to decide it, right? So generally the multiple of 5 meters will be taken, right? And at every 5 meter you are supposed to calculate what is the ordinate, right, or offset, right, that is y, right? So x becomes every 5 meter and you are supposed to find out what is y for that. You have the formula for both the values, right? For O0 there is one formula and for OX there is one more formula. So you need to understand that you are supposed to calculate the ordinates. Clear? Now if I have to calculate the ordinates, first I should know what is length of long chord. So without length of long chord it is not possible that we will find out O0 or OX, because the formula of O0 on OX consider or will have capital L in it. So when you have capital L in it, and you must have to have a value of capital L. Now I have the formula for finding capital L, right? So capital L, that is length of long chord, will be 2r sine delta by 2. Sorry, 2r tan delta by 2. This is what we have derived in the beginning of the curves session, right? So just confirm the formula. So L is equal to 2r tan delta by 2, right? So how we have done that is by considering the right angle triangle here, right? So one of the side is this and we know the hypotenuse, right? So using this formula, using this triangle, we have found out what is L by 2, right? So now I will show you the calculation done for this. So first let me confirm the formula. So length of long chord is sine delta by 2. It is correct. So length of long chord formula is 2r sine delta by 2. Now I will substitute the values. 2 into 100 into sine delta is 30 by 2. Now if I have to calculate this, so sine 15 into 2 into 100. So that comes around 51.76 meters. So this is the length of long chord. So this length AC is 51.76 meters, right? So half of this will be 25, right? So half of this will be approximately 25. So that means what? This length is 25, right? So if I consider this as 0 or not, 0 distance, because x is equal to 0 here, right? So this I can consider it 5, then 10, 15, 20, 25, right? Because on the left hand side you will have 25, on the right hand side you will have 25 meters, right? So totally it will be around 51 meter. It need not be a round number, right? And you need not to go till the end, because the last point is A itself, and here the last point of the curve is C itself, right? So after 25 meters, so the length which is going to remain, that is half of 1.76 this side, half of 1.76 this side. So that becomes one more length, and the point is on the tangent itself, because point A is a point on tangent as well as point on curve, both, isn't it? And here also point C is point of tangency. It is point on the curve as well as it is point on the tangent, right? So you need not to worry about the last point, right? See how many will fit within that. Since in the problem he has not mentioned what is the length to be considered, so you can consider x is equal to 5, 10, 15, 20, 25, go on substituting, you will get what is the value of OX, right? If not, you can even select different number like 10, 20, 30 like this, right? So if you go for multiple of 10, so you hardly have two ordinates, so which is very much inconvenient for drawing the curve in the field. So that is why having it 5 meter will be generally what is acceptable, right? So I am going to take up that value now and I am going to calculate the ordinates. So to calculate the ordinates, first I will begin with O naught, right? So that is mid ordinate. We have the formula for that, right? So we have the formula for mid ordinate as, in terms of longchord, r minus square root of r square minus l by 2 whole square. So r minus r square, root of r square minus l by 2 square. R is 100 minus square root of 100 square minus l by 2. L by 2 is this L, right? So it is 51.76 divided by 2 square. Let me check how much is this value. So 51.76 by 2 square, then minus 100 square, so that comes around 9330 minus 100, so that comes around 3.408 meters. So that comes around 3.408 meters. So this height O naught is 3.408 meters, right? So this is the longest ordinate. So this is the longest ordinate, and any other ordinates what we are going to find will not have its value more than this. Remember that, because look at this diagram. So this has got the longest height. All other ordinates are the shorter ones. So definitely we are supposed to have the value of OX, O5, O10, O15, O20 or and O25. So all the values must be less than this, right? I will show you one value or calculation for one value, one or two values. So you are supposed to calculate the values for the other length of X, right? So to show you the calculation of ordinates, so this value is required for the calculation of OX, because OX has got this formula. So the formula for OX is root of r square minus x square minus r minus O naught. It is OX is equal to square root of r square minus x square minus r minus O naught. So O naught is the one which you have here, so that is why it is required. So square root of r square, that is I am finding O5 now. O5 in the sense x is equal to 5. So from here to here the distance is 5. So x in both the direction. You need not to calculate on either side. You just calculate for one of the side, the other side will be same, right? So the y values will be remaining same. So that is why. So calculate only for the half portion of the curve. So x is equal to 5 now, that is why O5. So r is 100 square minus x is 5 square, right? Minus 100, that is r, minus O naught is 3.408, right? So this is a constant term, you can keep it constant. So 100 minus 3.408, so that comes around 96.592. Then this value 100 square minus 5 square, that is 25, so 9975, so that comes around 99.87, right? So this minus 96.592, so that comes around 3.28 meters. That is O5 3.28 meters, so it is less than this. So further value, that is if I have to calculate for O10, right? So O10 will be 100 square minus x value will be 10 now, right? So the next value will be same as the one what we have there, because r minus 1 it is. So 100 square minus 100, 9900, so square root of number 900 minus 96.592, so that comes around 2.906 meters. So if you just look at this value, it is less than this. So in a similar way, you are supposed to calculate for O15, O20 and O25, right? So there are 5 ordinates, right? So for x is equal to 0, O0, for x is equal to 5, 3.28, for x is equal to 10, 2.906, and it is still going to be lesser and lesser. So once you have got these 5 values, same 5 values will apply on both the sides, right side as well as left side, right? So this is how it is done in the field, right? In the field, as I have told you, you will have point A and point C marked on the tangents, right? Join AC, right? In the field I am talking how it is done in the practical field. So join AC, bisect it. So once you get this point, so that is the point where mid ordinate is, and you are supposed to have the perpendicular. So to have the perpendicular, you have number of methods like 3, 4, 5 method or optical square or anything. So using that, you are supposed to have perpendicular and measure this height O0 equal to 3.408. Measure that and mark a point on the perpendicular, right? Now on the same long chord, from this point measure 5 meter on this side and measure 5 meter on this side, then have perpendicular there. Then those perpendicular must have the height equal to 3.28, because O5 is 3.28. Mark those points. Then 10 meter, 2.906. These heights must be 2.906. So in a similar way, go on completing this. So once you get those points, you are just supposed to join those points, and that will be the required curve of required radius. So joining those points will give you the curve of radius 100 meter. So this is how the actual curve is drawn for the roads in actual field, right? So this is how the problem is to be solved, and solving it for half side of the curve is enough, right? So I am requesting you to calculate values of O15, O20 and O25 in a similar way, right? And meanwhile, I am going to give you some more problems, and I request you to solve the problems in a same way. So when I will be giving you the problem, I will give you chainage of P, delta, radius. So using these 3 values, you are supposed to calculate the remaining things, right? Okay, so this is how the problem is to be solved. In the next session, we will take up the next method of setting out of curves.